Okay, what we're doing now is we're going to do functional groups that contain oxygen. There's quite a bit here. I would go through and look at some videos. I know Khan Academy does quite a good job on this. That's K-A-H-N. So what you'd want to do is say, hey, Khan Academy naming alcohols, Khan Academy naming esters. Now, remember, there's two ways of naming things. There's the common way. If they ever say common, we're not doing that. We're only doing systematic ways when we're doing tests. So this first group is called an alcohol, and that's an OH. So if I put an OH there, this is going to be 2-butanol. That's an OL ending. It's a suffix, meaning it goes at the end of the name, not at the beginning of the name. Once again, we could put two OHs there, so we could do 2,2-dibutanol or butanediol. So I could have put another OH there. All the rules are exactly the same. Now, if you want to know what end to start counting from on a molecule, you always find your highest rated functional group. So an OH would be higher than a double or triple bond or a methyl or an ethyl. We are not going to emphasize that too much in this course. Okay, so now what we have is we have a single bonded oxygen. So it's single bonded to a carbon chain and single bonded to another carbon chain. Circle the longest carbon chain. That's ethane. The shorter one, I'm going to do this, and I'm going to call it methoxy. This is a prefix. It comes out front. This blurs together. There is no space there. It's on the first carbon. It's 1-methoxy. Let's do another one. I'm going to draw my longest chain sideways now, and I'm going to go like this, and I'm going to go like this. So now I take my longest chain, 1, 2, 3, 4, 5, so it's pentane. And on the second carbon is a methoxy. On the third carbon, there is a ethoxy. Sorry for my writing. That says 2-methoxy right there, 3-ethoxy. So I've got 2 carbons here on this side chain. Now, what you're going to see is that we have a number of groups that have double bonds. If it's just a C double bonded to an O, they're called carbonyls, but there's 2 types of carbonyls. If the C double bonded O is on either end of the chain, it's called an aldehyde. So this one is an aldehyde. So that's an alcohol. That's an ester. Sorry, that's an ether. This is an aldehyde. And so it gets an L. So it's prop and now. So we just changed the ending to AL. Hey, if you're doing a test and you don't know what to take off, like I took the E off the end, don't worry about it. I'm not going to nick you on those little things. That C double bonded O is on the end of a chain. It's on the first carbon. Folks, remember, if the C double bonded O is on the end of a chain, it's called an aldehyde. If it's anywhere in the middle, it's called a ketone. So they look exactly the same. So this is 2-butanone. So instead of using AL, I use ONE for my ending. Whenever you see what looks like an aldehyde and an alcohol together, that gets one name. This is called a carboxylic acid. Very important in your everyday life. All of these are very important in your everyday life. So for example, a ketone would be like the smell of a rose. Carboxylic acid would be like if you ever eat candy, it's got citric and malic acid in it. If you get bit by an ant, it's got formic acid in it. So that's that sting that you feel. So these are always on the very end of a chain, and you will see an aldehyde and an alcohol together to form a carboxylic acid. This one is called butanoic acid. So there is a space between the oic and the acid. It is on the first carbon. The trickiest one, okay, these ones are the esters. You deal with these every day in your life. Your clothing may be made up of esters, or if you eat any processed food at all, the flavors that you're tasting are esters. So your first trick is to find the C double bonded to an O. So this is your C double bonded to an O chain. There's two of them. It's ethanoate. Okay, then you find your other chain that doesn't have a C double bonded to an O. That's propyl, because it's 3, and we give it a YL ending when it's a side chain, and there is a space there. I highly suggest you watch a couple of videos on doing this, or you rewind this a few times to get used to it. Okay, I'm going to change this just so we're doing something a little different. We found the C double bonded to the O. It could be on the right side, it could be on the left side. In this case, it's on the right side. This is butanoate, and that is ethyl. It's a 2-carbon group. Leave a space. Ethyl butanoate. I believe that is banana flavor, if I'm not mistaken, but all of these esters are different types of flavors. Now, I went over quite a bit there. I went over alcohols, I went over ethers, aldehydes, ketones, carboxylic acids, esters. Folks, there are a lot of different side groups that we can put on our carbon chains that have O's in them. So an example of where you might find this is in sugar. You've got OH's on your sugars. Okay, so these are all around you. All that happens is when we put these groups on that have oxygen, we change what the carbon chain does. So for example, propane or butane, which just have carbons and hydrogens, or hydrocarbons, are used as fuels. These would be used as other things in our life. There's more than 500,000 of these known to man, so they are quite important.